Hi, thanks for joining me. So today I'd like to talk about the limitations of relative searching. I've spoken about relative searching before in my dumping a script playlist and also in my video about City Hunter and some things like that. But today specifically I want to talk about the ways in which it can go wrong and what you want to look out for, because this can be an extremely useful tool. I've gotten tons of mileage out of it. In fact, whenever I figure out a text encoding or dump a script, invariably I have to use relative searching. Now, it's considered kind of a beginner technique because really my skills in ROM hacking, so to speak, are only beginner to intermediate. It's one of the reasons why I focus on Japanese translation and not really the technical side of hacking, because I just dabble in this stuff. But it's still something that's good to know about. So, for starters, let's take a look here at Mado Monogatari A, Doki Doki Vacation or Vacation. We can see these graphics tiles just kind of stored consecutively in the ROM. And they're stored in like the order that a lot of these, especially these old 8-bit games do. They're all going to have slight variations, but at least we can see like the numbers. They're all in order, 0 through 9, all the numerals. We've got, the Japanese alphabet here, hiragana script. This is a, I, U, E, O, ka, ki, ku, ke, ko, etc. It's not missing any letters that I know of. If you guys have taken a Japanese language class before, you know that the vowel groups are a, ka, sa, ta, na, ha, ma, ya, da, and wa. Specifically the wa group here at the end, you've got wa, n, and o. This frequently, I think O technically is part of the wa group, so a lot of times you're going to see it actually go wa, o, n. This can vary a lot. I see it about 50-50 in games. Sometimes the O even is just like somewhere else and it just ends in like n. So, if you're relative searching, I try to never include O or n in my relative searches. But you see this, you've got the small hiragana here. You wouldn't want to include those in a relative search either, really. But katakana, this is all in regular order. The English alphabet, this is all in a regular order, okay? So if you searched on anything that was like, let's say, all English alphabet characters, out of as a relative search, chances are it's going to come up with this. If you search for like any of all hiragana characters, chances are it's going to come up with a relative search, assuming that the game, the encoding is encoded in the same order that the font tiles appear. Now, here's an example of Kuni-chan no Game Tengoku here. This is actually running in an emulator right now. And you can see here, this is just speculation on my part, but I think the reason that the order that tiles are stored in the actual ROM tends to be the same order that the text encoding uses is that a lot of games will actually just load a block of data into memory, and I think that's what we're seeing here, this tile view. I assume, again, I'm making a lot of assumptions here, so don't, just this disclaimer for this part. I assume that this is all loaded into RAM, and it's all just in the same order that it is in the ROM. Like, there's no point in programming it to rearrange these, for instance. And you can see they all kind of have a byte value associated with them. If I hover over this, it's like, or I guess I have to click on it, but this is like, 10, 11, up through like 19, 1A, etc., etc. So I think it's typically just easier. I've never seen a game that, if I can see the order of the tiles in the ROM, that the text encoding does not match the order. But I think conceptually it doesn't have to. I think like if the tiles are like 0 through 9 and they wanted to make the order reverse or something like that, and so 9 was actually tile 1 and 8 was tile 2 or something, like, they could do that. I don't see why you couldn't. Anyway, what they do, however, frequently is, is have this in just some sort of non-standard order. This is about as non-standard as I've ever seen it here. Fire Mustang on the, the Mega Drive or the Genesis, the Sega Genesis here. This is just like completely random. You've got 1, you've got do, you've got Po, I think that is. Actually, I think I got this, yeah, just slightly off there. Da, shi, re, 9. You know, even if you don't know the Japanese alphabet, you know, 9 does not come after 1 with a whole bunch of stuff in between it. So this is clearly very weird. And when I was trying to do relative searching on this, nothing was coming up. So, you know, the first thing I'd like you to recognize is that if you're doing relative searching and things aren't coming up, I mean, for starters, it could be double byte encoded as opposed to single byte encoded, so you might want to take that into consideration. But, which this is double byte encoded for some reason. It doesn't even have to be, like, there aren't enough characters in this that you need double bytes. Like, they just decided to do that too. But yeah, it could be something weird like this. So, you know, I did see this in this tile editor, and I was like, okay, so because this game in particular, it's a shoot 'em up, and it's set during like World War II. So you've got these dates alongside some Japanese text. That was important. So for this instance, what I actually decided to relative search on is, let's say, like 1941. In fact, I probably would have done maybe like 1941.12.8, and I don't know what the dots are, so I could just skip the bytes. But I tried searching on this, and so what I would have to do, of course, is actually just count this out. You know, this is like what, 47, let's say, 9. And then you got 4, which is like 57, and these aren't necessarily the values, you know, but at least it gives you the relationship of the values to each other, and using that relationship I was able to get a hit, and then I was able to figure out, okay, this one looks like the one that's right here, and I was able to start using that as a Rosetta Stone, so to speak, to figure out the text encoding in here. And, you know, I mean, it's pretty clear, because it does follow this order and I can see it. I was just able to then start, you know, typing it out, and this was all correct. So, you know, so that was great. This gets even weirder, though, just in this particular instance. I figured you guys would be interested in seeing this. So this all works great for this ending text, but this game has these little descriptions before each of the stages, and it's a similar format. You've got a date, and then you've got some text to it. So again, for whatever reason, the programmers decided to just mix in the font tiles that they needed along with the graphics tiles that they needed for each of these screens. Okay, so here we can see we've got like 9, 4, 5, 2, 8, 1, and then we've got some, you know, Japanese characters in here and all this stuff, and that's all along with like a map. This isn't necessarily this exact same image, but they're all pretty similar. You know, the image tiles for this map, for the flag, you've got the stars and the stripes and all that stuff. Really weird way of doing this. And what it means is that for literally each screen, for each stage, and there's, you know, whatever, 8 stages or something like that, like maybe I could go in and figure out, like, maybe these line up so that, like, if this was kind of like 07 and this was sort of like 13 and 14, like I could, again, maybe relative search on this based on this, make like a separate table file for the text encodings for each screen that is used before each stage, and that's a huge pain in the butt. What I realized is easier, since this is a shoot 'em up, it's totally linear. There's a video of it here on YouTube. I just transcribed these screens. Now that's obviously like not something you could do for like an RPG or something like that. Anything that has text that, you know, isn't all going to come up, or there are just copious amounts of it. If you can miss text in a playthrough, that's not really going to work. But in this case, might as well. You know, it was way less work than like figuring out a separate text encoding for each screen in the game. It's an interesting way of doing it. But you know, this table was useful for dumping the ending, and it saved me transcribing that whole ending. So in that case, you know, it did save me work. You also might not be able to see the font tiles in these graphics tiles. You just might not have access to that information. I talk about that a little bit more in my City Hunter video. If you know in your head what some of the orders of things could be, you might be able to luck out and stumble across something. This is SJIS encoding. It's kind of a more, it's a double byte encoding anyway, so it has a lot more values available to it. And the reason why, like, these old games in particular, especially these 8 and 16-bit games, tended not to use these standard text encodings is they wanted to just save space. You know, they were almost always custom. But you can see here that this has like the small hiragana character, then the large small e, large e, e. So immediately you can see why, if something was encoded, maybe not even just in SJS, but in this order, you wouldn't get a relative hit on it if you were searching as if it were just I, U, O. And then same here with these voiced characters. You've got like ga in line with ka, you know, ki, gi, ku, gu. So that's another way that this could be stored in a game. So if you're running into trouble with your searches, like for instance, you might search on numbers. You might search on characters that are grouped in like the first part of an alphabet, because I've seen stuff where like even like especially the English alphabet like maybe is just cut in half, like maybe half the English alphabet is up here after the numerals, and then the last half of the English alphabet is down here after all the hiragana happens. I've also seen stuff, especially with the English alphabet, but this could happen with any of the character sets, where there are just characters missing because they only used the characters they need. So maybe you've got a couple of English words in your game, and so maybe you only use the letters that you need for those couple words that you used, and you leave out, you know, however many it is that you can leave out. And that can happen with katakana, it can happen with hiragana. So there are all kinds of reasons why your relative searching could fail. Occasionally, you know, you can get lucky and get around that. If you have access to like a tile view like this in an emulator, you might see a weird ordered font loaded up, kind of like in Fire Mustang here. You might be able to see it in a tile editor like this. You might not be able to see either of those things, you know. So it's an interesting puzzle for me. It means that there's a handful of games I'm just never going to be able to get into because I just don't have the skills. But there's an awful lot you can do with relative searching. I find it an extremely useful tool, but it definitely has its limitations. I am going to make probably at least one more video before the end of the year, so I hope you guys are looking forward to that. And I hope this was interesting. I hope you guys catch me, you know, again next time. Thanks for watching.